integrating to get inverse trig functions. So right off the bat, I'm just going to give you the formula here. Here's the formula to get arcsine. Here's the formula to get arctangent, and here's the formula to get arcsecant. If I've got 1 over the square root of a is just some constant squared, then u is the function here, minus some other function squared. The antiderivative, the integral is going to be arcsine of u over a plus c. So a here is always some constant, and u is the function. Down here then, the big goal of this whole thing is to figure out what is a and what is u. This one's not too tough. A squared is going to equal 9, so that means a is going to equal 3. U squared is 4x squared, which means u is 2x. So I'm going to change this into basically this exact problem right here. This is 1 over a squared plus u squared. Now to do this though, I am going to have to find du. The derivative of u is going to be just 2 dx, or 1/2 du is equal to dx. So this problem, after my u substitution, just became 1/2 of 1 over a squared plus u squared du. 4x squared is the u squared. The a squared is the 9. And instead of dx, I'm integrating with respect to u, so I derived that to get du is equal to 2 dx, or 1/2 du is equal to dx. Now I can just follow the formula. 1/2 of the arctangent of u over a, but I've also got to put 1 over 2. So 1 over a is 1/3, 1 over 3. And then we'll have the arctangent of u over a, which is 2x over 3, plus c. Simplifying, this would give us 1/6 arctangent 2x over 3 plus c. That is my answer. So the whole goal here is to figure out what is the a squared and what's the u squared. What's the a and what's the u. On this one, it's going to be a little bit more... On this one up here, it's going to be a little bit more sneaky. Now let's do this one down here. It's going to be a little bit more sneaky. It looks like it's going to be arcsine right here. So if it's going to be arcsine, that means the a has to be this number right here. A squared is equal to 1, so a is equal to 1. And u squared is going to be 4e to the 6x, which means u is just going to be 2e to the 3x. Let's derive this. Du is going to be 2e to the 3x. Chain rule. The derivative of the 3x right here is 3 dx. Simplifying a little bit, 6e to the 3x dx. You'll notice on top here, we don't have 6e to the 3x, so let's make it 1/6 du is equal to e to the 3x dx. Excellent. Now let's put it in terms of u then. This we said right here. That's 1/6 du. This right here is the u squared. This is the a squared. And so we're left with 1 over the square root of a squared minus u squared du. Hey, that fits perfectly into this formula here. That's amazing. So this is going to be 1/6 of the arc sine of u over a plus c, which gives us 1/6 the arc sine of 2e to the 3x, all divided by 1. And let's simplify one more time. There we go. Slide that over so you can see it. Once again, I just had to figure out what the a squared was, what the u squared was, and then naturally what is the u. Then derive the u to get the du, so we can get rid of all that other stuff. And there we get our answer. You won't see anything this challenging or horrible on the AP exam. You might see it on my test, but you won't see anything this horrible on the AP exam. Same thing for this next one. These are both kind of just showing off if you are an intellectual stud muffin. Can you figure out the algebra to this? This one up here, it doesn't fit. The x minus 3 on top doesn't fit any of the formulas we have over here. Let's go ahead and find our u and our a. The a squared is going to be 5, so a is going to be the square root of 5. That's okay. We can have that. U squared is going to be 36x squared, so u is going to be 6x. That means du is going to be 6 dx, or 1/6. Du is going to be equal to dx. The problem, though, is we still have this x up here. And no, we're not going to go about solving for u and then go back and substitute it in here. We're not going to do that, actually. What we're going to do here is we're going to divide and conquer this. We're going to split this up into the following. X over square root of 5 minus 36x squared dx plus the integral of -3 over the square root of 5 minus 36x squared dx. Scoot over a little more. Now this right here does fit into one of our formulas. That's like the formula for the arc sine. This one right here does not fit into one of our formulas, but we've done this before. Because the derivative of what's inside here is going to be what's on top. Not exactly, but scalar multiplier of it. So this one over here, I'm going to use this substitution for this problem over here. I'm going to kick the -3 out front. The a squared, of course, is a squared is 5, so a is the square root of 5. The 36x squared we said was u squared. The du The dx becomes 1/6 du. So I'm going to kick the 1/6 out front here. Multiply that by 1/6. And that's really just going to be negative 1/2. And that's going to be the arc sine. Arc sine of u over a plus c. There's the formula. This is exactly what we have here. So let's go ahead and take, so that's going to give us the arc sine of 6x over the square root of 5 plus c. This one, though, I have to do a separate u substitution for. This one, u is going to be what's inside here. U is equal to 5 minus 36x squared. So that means du is going to be negative 72x dx, or negative 1 over 72 du is equal to x dx. That is that right there. Now, if you don't want to do u substitution, we don't have to do u substitution. How about we do w substitution? It's really just some other letter. Doesn't matter what it is. But I love u, so we'll stick with u normally. So using w substitution here, I'm going to get negative 1 over 72 dw that just became 1 with the dw there. This is going to become the square root of, well, all that was the w right there, so that's just a w on the inside. Rewriting this, negative 1 over 72 times the integral of w to the negative 1/2. So, just using the power rule, this is going to become w to the 1/2, 1 over 1/2, or just 2. We still got the negative 1 over 72 out front. And after a little simplification and the substitution by plugging this back in, this is just going to be the square root of 5 minus 36x squared, negative 1 over 36 times that. So that problem worked out to this. This problem we figured out was 1/2 the arc sine of 6x over the square root of 5 plus c. Whew! Now that's a problem right there. Feels good, doesn't it? That was a lot of work just for one problem. Once again, the AP test, you probably won't see any problems like this on the AP exam. But they're fun. So you get a problem like this, you should be proud of yourself. That's some complicated algebra. That's some complicated substitution. And overall, a very, very complicated integration problem. You get this, do a self high five, take a picture of your hand and send it to me, and I will give you a high five back. Send you a picture of my hand so we can high five each other. You get one of these problems, that's impressive. You should feel proud of yourself. They're normally not this tough. And we got one more problem here. Again, most problems aren't going to be this involved or long, especially not on the AP exam. So, completing the square. This problem right here looks like it should fit into the arc sine mold, but it's not 6 minus x squared, it's 6x minus x squared. We don't have an a squared value in here. Yet, we will. Because here's what we're going to do. I'm going to complete the square here. By factoring out a negative first, I'm going to make this x squared minus 6x. Now, if I wanted this to be a perfect square, if you recall, what I do is I take this number divided by 2. Negative 6 divided by 2 is negative 3, and I square it. Negative 3 squared is 9. I'm going to add 9 onto the end. Why do I do this? Because when I factor this, this is going to factor into x minus 3 squared. Now, here's the thing though. If I'm going to be adding 9 to this, I also have to subtract 9 from this. But in doing that, I'm going to break it up into two parts. Negative x squared minus 6x plus 9. Then once I minus negative 9. Remember that negative sign carry through there. So those two negatives are actually going to make this positive. And if I work backwards from this, I should get the same thing. So this right here can be rewritten 9 minus x minus 3 squared. And that can replace this part right here. So now I have the integral of 1 over square root of 9 minus x minus 3 squared dx. Well, that fits perfectly into our arcsine formula. This is a squared. This is my u squared. And so I'm going to come down here. A squared is 9. U squared is x minus 3 squared. So that means a is 3 and u is equal to x minus 3. Change everything to u. du is going to equal 1 dx. Well, that's pretty. At least they cut us a break there. And I'm going to get 1 over the square root of a squared minus u squared du, which is the arcsine of u over a plus cookies, or the arcsine of x minus 3 all over 3. There you have it. And we got that by completing the square. I'll show you one more example of completing the square because that's the hardest part, just getting it set up right there. So let's say I had 10x minus x squared. How am I going to do this? Well, first thing I'm going to do is I'm going to factor out a negative just because I like working with positives instead. X squared minus 10x. I'm going to divide this by 2. Gives me negative 5. Squared it, I'm going to take plus 25. Now, if I'm adding 25, though, I also have to subtract 25. Now, the negative here is because there's a negative in front of this whole thing. So this is going to give me negative x squared, x minus 5 squared. Those two negatives make it positive, plus 25, or 25 minus x minus 5 squared. So that's how you complete the square for these. Once again, you probably won't see any AP problems this long or involved or this tough, but you'll have a couple of these. Give them a shot. If you don't get it, don't freak out. It's not the end of the world. If you get it, give yourself a high five, because these are pretty darn tough. It's good to try these problems once in a while, though. Give it a shot, see how it goes. All right. So that is integrating to get the inverse trig functions. Figure out what a squared is, figure out what u squared is, and go to town. Thanks for watching.